So next up, we have Massimo Lurashi. He's from Subsquid. And Massimo is a developer advocate at Subsquid. And to give a quick introduction to Subsquid, Subsquid is the blockchain world's data backbone, providing a framework for robust multi-chain APIs and analytics on 33 networks. And that stat may be even a couple months old. I'm not sure if it's...
Yeah, like there's networks coming and going, depending on like if we pull support from test networks, and if we had obviously new ones. But you're spot on the introduction and the overall overview. I'm gonna try and do some more, go in depth into this with the presentation. Just a quick short presentation I have prepared, and thank you for having me, by the way. Okay, so thank you again, Kevin, for the introduction. The title of this is Indexing to Enable Web3's Mass Adoption. And the reason for this is because for me, I'm coming from Web2. I was looking at blockchain technologies as sort of not just the new ways to sort of empower people with new financial means, but I was definitely seeing the potential in changing people's lives and changing how development is made. And so far, like there's been some obstacles, some challenges, and most of them are related to data, but I see them also from the user's perspective. And so this is why I'm trying to join the two topics into this presentation, which I hope makes sense. Let's start with introducing myself. Hi, everyone. My name is Massimo Luraski. The pronunciation of my surname is challenging to some foreigners. I'm a developer advocate at Subsquid. These are my socials. I'm leaving them a little bit on screen, so people, if you want, can check me out. These are 3 I's, and like caps I's, not 3 L's. And moving on, the agenda for today is a quick Subsquid introduction, some updates, because I've been a guest of the sort of events that Moonbeam organizes from time to time, but it was, like David said, a while ago, and we have new features that or new releases that we have made in the meantime. And then we have a coding demo, finally. So let's move on. As I mentioned, I come from the traditional web, what we call today Web 2 development. And the reason for this is to introduce what I think we are kind of leaving on the table as we try to create this new world, which we are calling Web 3. There's a lot of technologies that have been built by and basically have become industry standard by today. And the first and foremost that like I worked as a data engineer, the first one that comes in my mind is how we treat data. And there's like a tool for every task. But big companies have an approach to data that is try to find the best tool for the task at hand. So there's definitely some data ingestion going on, and there's destinations for different like for the different reasons or for different things that I want to do with data. So I have a data lake, I have data warehouse. I haven't shown it here, but there's usually cache for improving the performance of web pages. And I think that this is not happening in blockchain, like decentralized applications. What actually Web 2 companies achieve with this is what we see today, what we are able to do right now. They can serve millions of users. They have millisecond latencies. They can do, and sometimes with nefarious like things in mind, do real-time data analysis to generate insights and do informed decisions. But first and foremost, they can scale on demand. Like, as I said, sometimes I feel like blockchain projects are leaving a lot of this on the table. What we experience oftentimes as users is we have high latency. There's definitely scalability issues. And a lot of this comes from the queryability of blockchain. Blockchain is not necessarily a technology that is made for this kind of storage. It's made for verifiability. It's made for security. It's not made for necessarily to be a web backend. And so there's also issues with type safety and extracting data types from the blockchain itself. But all of this is because we must not forget what we are here for. We want to maintain a decentralized architecture. And this is also like another way of introducing the sort of the trilemma of blockchain, where you cannot eat your cake, have your cake, eat it. You cannot have it all, essentially. The answer and the way we're trying to set a better standard for data indexing is modular architecture. I have visualized here what a typical data pipeline looks. And in our mind, a data pipeline is divided into stages. There's definitely the source, there's the ingestion, there's some processing, and then there's the presentation or the storage, or like this sort of like the final stages of it. And we have found some issues with other solutions similar to ours because in their monolithic approach, what happens is like different users, multiple users have the same ingestion step. It's basically replicated. Sometimes this leads to wasted effort. There's also like some attempts done to try and reuse already ingested data with practices, but this is almost like fixing something that was broken from the beginning, whereas we started with a fresh perspective and realized that this step, the first one, the ingestion, can actually be presented as a service. Like I highlighted here, that like when you start from a problem, you have a rigid structure, it's hard to evolve. Whereas with the first perspective, such as ours, we have modularized, create a modular architecture that is much easier to evolve as well. So for now, the structure that we have looks like this, and it's already changed from 6 months ago. And we have already plans to evolve it and make it even better. I'm going to show in a second why and how it evolved, but more on the modular architecture. I mentioned it, the ingestion service, or like I call it here, shared extraction service. It's called archive. The advantages that this approach brings is to lower the storage and computing power requirements. Essentially, if one service does the job for me and it serves multiple users, it means that all of these users and myself share in the cost of the service. This leads to a cost-effective approach and also better performance, because myself as a user, I can completely skip the initial part. I can use already ingested and filtered and queryable data to perform my processing on top of. This is what the archives look like. So we have taken the first part of the pipeline that I showed you before, and we have focused on this aspect. And if you want to zoom in, I have like part of my drawing skills or Figma skills. They're not the best. It's very simplistic, but if you want to zoom in into what an archive looks, it's essentially made of an ingestion logic piece of software, and it's made of a data storage. And this is one of the modules of the components of the module that can evolve. We have initially had Postgres databases doing this, and we found out pretty quickly that it doesn't have the potential to scale. When you want to serve a much bigger blockchain, when the number of blocks goes above a certain threshold, it starts to be an issue. So we started to look into different solutions, such as, for example, Parquet files. And this is all, once again, technologies that are already there and that the traditional industry has come up with, trying to solve issues that we are having right now. So if basically, like, we want to avoid using it, we're going to try and reinvent the wheel, which is obviously not very good. So what the archives services give you is they're essentially one less thing to care about. They take care of the boring part, the part that you don't have a hand over, because ingesting blockchain data block by block looks exactly the same for everyone. So why should you be interested in it? Once again, I want to stress the concept of a better performance, which is what we strive and try to obtain. How it does it in terms of performance from the developer point of view is that you can filter and query and access only the data that you want to. As a developer doing some sort of processing, which we're going to see in the coding part, you don't care about every block that ever existed in a blockchain. You only care about the blocks that contain the information that you want to access. And also in the block itself, you don't care about all the information stored in it. You care about the smart contract execution event, for example. So you can query those and let go of everything else, which reduces the network overhead, because this sort of request is towards the archive is basically asking only the information that it needs, and it's receiving only the information that it requested. I already spoke about the modularity and the potential for future improvements. So the second part, the custom processing that you as a developer want to apply, we call it squids. We are Subsquid, and the sub comes from the substrate part, the Polkadot SDK to build parachains. And it looks like this, essentially. It's built and designed to be customizable, as flexible as possible, so that it could serve the purposes that I showed you before. You can build a GraphQL API for, I don't know, an NFT marketplace or a DeFi dashboard, which is probably like most of the use cases that we have now. But the improvements that we have made is to make sure that our SDK can serve all of the other purposes. For example, we are very keen on serving the nascent Web3 gaming industry. We want to empower data analytics on top of blockchain data and data science as well. And so this is what our vision is. Zooming into a squid, it looks like this. It's composed of a processor where you can define your custom logic. For now, this is once again the modularity and the composability aspect. We are still using Postgres databases because usually when you filter down your data, there's a much lighter footprint, so databases use, but this is also the default components that we give you. The SDK is flexible enough that we have tried and tested saving data onto a CSV so that you can upload it to BigQuery and do data analytics on top of it. So this is, once again, and we're going to have very soon, I'm actually developing a demo for this. We're going to have it in our documentation website, a showcase of the flexibility of the SDK. So what a squid is, I already talked about it, but you can create your own data processing. You can define the schema if you want a GraphQL, if you want to use the GraphQL API in the end, and you can use the SDK and external libraries to essentially apply whatever mapping you want from the source data, which is the blockchain data. In the case of Moonbeam, it can be either substrate events or smart contract events as well, or transactions. You can pretty much the whole lot. You can also look into the substrate storage. You can look up the contract status, whatever you need, but you can map it to whatever schema you have decided. And we're going to take a look at that in the coding demo. But what we try to go further and help developers with auto-generated code to take care of some of the aspects that are not necessarily interesting for a developer point of view. Once you have decided the data schema, we create the TypeScript class corresponding to it, so that the interface toward the database, it's already managed, and you don't have to essentially spend time on it, effort, and it also reduces bugs, because if the process is automated and audited, you can rest assured that it's working. And if actually this process is manual, that's when you can have bugs. I already mentioned the flexibility and how we try to help developers, but we have sort of, like, I use often this catchphrase that the SDK is built for devs. It's designed to be easy to set up, and we allow for local development so that you can have a much tighter development loop. Oftentimes you go through a set of trial and error phases and loop cycles where you test your thing, you test your mapping, it doesn't work, but you have to launch it and execute it and see the like the syncing taking place to find the error. If you every time you have to deploy to a cloud, waiting for the deployment to happen, etc., it adds a like an overhead, and it adds like time to your precious development time. It makes the development cycle longer, and this is obviously not very efficient. It's almost like going back into the like 70s era of coding, where you have to book time to share the server, and it's simply not working. It simply doesn't work. The other way we can accelerate development is by allowing for faster sync times. If your application is syncing like 10, 100 times faster than similar solutions, you will eventually get to the block where there's maybe, in the case of Moonbeam, there's been a runtime change that broke your code, for example. So by getting there faster, you will fix it faster. But I spoke about local development and the difficulty of deploying to the cloud while developing, and that is true. But we also we have a deployment, a cloud hosting service that allows for serverless deployment, because in the end, when everything is ready and you're happy with what you have, that is like 100% a nice to have feature. It's very useful. It removes any issues that you might have with finding your own hosting. We also have type safety of TypeScript, which I spoke again in the beginning about the issues of extracting data and making sure that you respect the types of the smart contract on-chain. And we have code automated generation. We go from the definition of the schema to the TypeScript models. We go from the ABI that looks like this in the JSON format to the TypeScript corresponding wrapper. We have a mapping that maps the topic of the smart contracts to the corresponding decoding function. And we're going to see all of this in a second. I'm going to paste maybe later on the links to the documentation, but it's docs.subsquid.io. We have a template project which we're going to use, and if we have time, we're going to visit the aquarium, which is the hosted service. Now let's get to coding, because I already ate a lot of time from the presentation. Actually, I was almost forgetting about the updates. So in the Subsquid release, which is a code name that we gave to it because it's so fast, we deployed new archives which allow for batching. Batching is an amazing solution that allows you to essentially collapse multiple requests into a big one, and this removes all of the unnecessary overhead of networking and disk I/O, and so you essentially speed up your indexing 1,000-fold or 100-fold, depending on the cases. Like I said, we have added the ability to types to generate wrappers, like I showed you earlier, for EVM transactions, not just the events. We also allowed for contract stake calls, so you can access the status of a contract in real time. And we have deployed the aquarium. You can go visit it. Even if you just type app.subsquid.io, you should access it. And it's where you can host your squid. We also have a subscription, which was like an overly requested feature. This is essentially polling your squid and performing the query that you set, and making sure that you can you can be alerted. Your front end, for example, your client can be alerted when there's a change to this query. We also added the ability to deploy the GraphQL server with a cache to the API, so that you can essentially improve the performance. And once again, your if this is aimed at the front end, your users will be benefiting from the added cache. But like I said, let's get coding because time is sort of running out. We're going to develop today a Gremlins tracker. Gremlins is, for those who don't know, a collection from the Moonsama team, which is deployed on Moonbeam, and it's an NFT collection. So we're going to start with the setup. We're going to review the schema, generate the models, and generate the code. We're also going to take the API from the contract and generate the necessary interfaces for it to use it in our project. We implement the logic, and finally launch the database. I'm also going to show you, if I have time, in detail, the migrations which are necessary to apply the schema to the database, and launch the API, the GraphQL server, and profit. So let's start by visiting the template page. But before that, I have to remind the requisites, which are just simply Node.js and Docker. Node.js is for the project, Docker is for the local database. So let's visit the template page, which is in our organization's page, and it's called Frontier EVM, to distinguish between the Ethereum EVM. We're going to click on use this template. Let's call it, I don't know, workshop. That's it. Need to copy it, and then we should be, yes, nice. So we can go to our favorite IDE. In this case, I'm using VS Code, and I'm going to clone the repository locally. Yep. Let me now zoom in, because I have a big screen. Everybody is always commenting on the fact that it's not visible. That's good. So the template project, I'm going to spend 1 minute real quick. It's a fully finished and fully functional project. It already has its own schema. It's actually very similar to the one we are going to use in a second. And it also has its own logic in the processor.ts file in here. This is complaining because I have to, of course, install the dependencies. And so, like I mentioned, it's, if I can reduce this a little bit, it's already, it's coming with its own defined mapping logic. It's pretty simple, but I think that for me to be quicker today, it's better if I just start from scratch, like I'm going to show you in a second, from the presentation, and then I can go through it instead of explaining what's in here. So we can go back and we can close this. I already installed the dependencies, and we can start with the schema, like I said. To capture the transfers of NFTs, I decided, and it's should not be very controversial, to capture for these 4 entities. So I have the owners with their own tokens, and this is defining a relationship between them. It's defining what is called a one-to-many. So one owner can have multiple tokens, and it's defined by the brackets, which typically define an array. This annotation here essentially describes the fact that this field is actually not in the owner table, in the owner entity, is simply derived from the token table, from the token entity. So every entity in this schema will eventually be translated to a table in the database. That's why I'm sort of making this, using the two terms interchangeably. And it's doing this because there's a relationship established between the two, and I can use the owner field of the token entity to establish it and to create a derived field, which is eventually going to save space in my database and improve the performance. So I'm going to copy all of this, and then we can finish talking about it. That's it. It's actually similar to the one we had, but I just want to make sure that I'm using the exact one from the project. We also have the transfers entity, which is going to capture every time a transfer happened, every time the transfer function of the smart contract is going to be executed. It's generating an event, and that's what we're going to capture here with all of its information. Some of it comes from the event itself. Some of it we're going to use the blockchain information. So the timestamp is coming from the block. The block is this could be block number, is the height of the chain, at which we registered this specific event, and then the transaction hash as well. So we spoke about these two. The contract is actually pretty. I'm hard coding a lot of the information here, but I'm going to show you, if I have time, how to actually find it yourself. We can move over to the presentation because I have a lot of stuff to show you. First of which is the coding generation. What's gonna happen now is basically this command line tool is gonna read the schema and generate TypeScript classes and models for me. I should be seeing changes in this folder, which is the destination where I can find the generated models. Let's take the owner, for example, model here. It's the TypeScript representation of the owner entity defined here. So it has the same field, the same types, just in the TypeScript version. And I have the same thing here, sorry. Let's move over to the typegen. In order to perform this step, what's the usual path is to go to Moonscan, for example, get the contracts ABI from the contract tab, but the Gremlins contract is not a registered one, so there isn't one. I actually have it in a different repository, so I'm going to go and fetch it here. It's basically a standard ERC 721. It just has a few added functions. That's why it's non-standard. So let's go back to the presentation. Yeah, like I said here, we're going to copy it, create a source ABI folder, and we're going to paste the content into a JSON file, and then we're going to launch this command. So let's do it. In here, I already have this, which is what the template project comes with. I'm going to delete them so we don't get confused. The source ABI folder is actually already there, so I only have to create a new file, which we're going to call Gremlins. There it is. What we're interested in, by the way, is the transfer function event. Sorry, I keep switching it up, but it's very different. Like, function is when the smart contract execute. The event is something that the developer of the smart contract added as a bonus to signify that the function has been executed. And it has three inputs: the address from, the address to, so where the NFT has been exchanged, and the token ID. And then I can launch this command. It simply calls this command line tool, it needs two parameters, the ABI and the output. So where we want it to be the TypeScript file. And there it is. It has generated this for us. It contains a lot of stuff, but the most important ones for us are the transfer event type. It's an interface that we can use because it contains the necessary fields and types so that we can exchange the data. It contains the decode event function, which is used in here, and it contains this events mapping that maps the smart contract event topic to its decoding function. This is the main thing that we're going to be using in just a second. I think that all of this squiggly here is just essentially TypeScript linting issues. There's actually no errors in there. It's just my configuration is very strict with linting. So we can move on to the logic. I think it's better if I copy over it and then explain it really quickly. And so we can go to the processor. There it is. And let's actually get to the top and close the terminal. So there's a few imports in here. There's Subsquid libraries. There's the models that we saw before. And there's the ABI file that we just saw. I have the hard-coded contract address in here. And the first thing that we are doing here is we instantiate the batch processor. We call it like this because it's returning data, and we can ask data to it in batches. There's also a normal substrate processor, but we essentially basically decommission it. It's legacy by now because this is so much better that it's not worth using the other one, the old one. We configure it with the data source. We have a library that looks up the existing list of archives, and we want the Moonbeam. We also need the chain, and I'm going to explain in a second why. And the most important thing here is we essentially notify or configure our processor to make requests to the archive about this specific EVM log, so the events, for this specific contract. And the function allows us to essentially filter down and configure our request. I can put a star in here, and I can essentially say I want every smart contract on Moonbeam. I want every event that has the signature transfer. In our case, we're not that suicidal. We can just try and be more on the topic and say I want only the gremlins. And specifically, I can also have specify this as optional object, which allows me to configure a further filter. So if I don't specify, I'm basically requesting every event from the smart contract. In this case, I'm filtering it down, and I only want the transfers. Then we have the run function. This is where we tell the processor to start making requests in batches. And we have an asynchronous function here, which is basically the core of the logic. It's I think of it as a callback function. So every time a request is successfully returned by the archive, this function is executed. And this is where I can define my logic. I use helper functions in here, like this handle transfer and this save transfer, to sort of like shrink it down and make it more modular. What the end handle transfer does is it's using the gremlins ABI wrapper that we saw earlier, specifically the decode function, to decode the smart contract event and extract the fields from its execution, right? And these are the fields that we're going to need and we're going to use to be saving in the GraphQL file. Next, as I said, some of the some of the, how I say it, like some of the data, some of the information that we're going to save does not come from the EVM log itself, from the event. It comes from the block, itself, or from the event, more generic event. The next thing is we save, and this is slightly more complicated, and I'm going to show you in a second why. Something I skipped to be quicker, but it's useful for me to highlight it. This is a nested double for loop, and it's necessary because when this function is executed, it receives a context, and this context is a collection of all of the blocks that we have been given that compose this batch. Because, like I said, we communicate with the archive in batches. We request for a certain number of events and a certain number of items, because I can essentially subscribe for more and receive more non-homogeneous items. That's why we call them items in here. I can have EVM logs, substrate events. It depends on how I configure the execution, essentially. And that's why I have to loop through the blocks and through the items inside each blocks. I have a check here that is not necessary right now because I only have one type of item I am subscribing, and it's an EVM log by definition, for sure. But I still check it just to, this is a demonstration. And so once we have processed them all, we essentially store the data in this interface in here. We save an array of this interfaces, and then we use the save function to try and generate the other entities, the contract, the transfer, and the token, and the owner, sorry, and save them all at the very end. This is assuring that I'm not spending too much time in I/O, and I save in batch at the very end, allow me for better performance. I have one trick to show you, and one powerful demonstration, practical demonstration of why archives are so useful. I'm going to comment out this line, which is the only line that has a direct communication towards the RPC node. And I'm gonna make build. Yeah, if I can spell right. Yeah, I spent a lot of time on this, but it was very important. So the next thing is to launch the database and to apply the migration. So that's what I'm actually going to do, make up. This is essentially spinning up the PostgreSQL database that I have in here for local development. It's defined in the Docker Compose. And I have some migrations files in here. I don't have time to show them to you, but essentially migrations are a collection of SQL statements that apply the defined database schema to the database. I'm going to say make migration to create a new one, and we should be good to go. Boom. We can now launch the processor, and I want to show you how fast the execution is. This is a couple of statements. It's just the execution of the migration, creating tables, etc. And you can see it's already mapping. It's doing its thing, right? We have average. The first few blocks are very heavy with events because the NFTs were being minted, but it's going to pick up, and the average is like 4K. So that's pretty much it. But I want to show you really quickly. If I turn it down and turn it back up. So this is resetting the database. And if I do this, see that it's taking actually a couple of minutes at least to start, because what this does, it's using the ethers. I think I have a problem with the RPC, and that's why, like I said, the RPC network, the RPC endpoint I think it's failing me for some reason. I had an issue and I changed it, but I guess this one also. My point was essentially that it's going to slow down the process a lot, because instead of communicating directly with the archive in batch, for every token, it's going to ask the status, asking the token URI, because that's the only way to obtain it. And it's going to eventually slow it down. It's still fast, but not as fast as it could be. I'm going to go back to, well, I don't have time to show you this, but if I launch make serve, well, I think I can really quickly. But it's going to show, it's going to open up a GraphQL playground with this. Now it's empty because I just reset the database, but essentially that's it. I can query and I can use all of the powerful stuff that GraphQL comes with by testing it out and playing with my data. That's pretty much it. I just want to show you really quickly that this project is actually available on the Aquarium, and the Aquarium is the hosted service. I have my own squids in here, but there's so many actually. These are all projects, and this is the one we have been looking at today. These are all projects that follow the same path that I just showed you.
Incredible.
Yeah.
And other people can upload their stuff to the Aquarium as well, right?
Yes, this is what I wanted to show, but I don't have time. We have a command line tool. Actually, let me see if I can really quickly. So if I type npx sqd squid, this is how you can interact with the Aquarium, right? And you can deploy, update, release, whatever, you name it. You can. It's very useful actually for debugging to access the logs as well. You have to go to the website and create the entity first, but that's sort of it. Yeah,
for sure. Thank you so much, Massimo.
Yeah, thank you. Thanks a lot. I just had a couple of slides, but yeah, please leave a star and be updated. That's it.
I also want to give a shout out to the thank you for being here. I also want to give a shout out to the Moonbuilders Academy. You put together an amazing course, which isn't yet live, but that'll be the first thing that happens after Illuminate.
Fantastic. Awesome. I put a lot of work into it. I hope people can benefit from it. There's multiple projects. You can see a lot of aspects on what you can do with Subsquid.
Absolutely. And the link for that is academy.moonbeam.network.